In this video, we are going to have a look how we can actually simulate not only software, but also a little bit of hardware and connections on different boards and different peripherals without having the hardware to test our ideas very quickly. And it can be useful for people who would like to learn a little bit about how to do all these circuits. And first, I would like to say, so on the right side, we can see this simple connection. That's the circuit what we kind of built, correct?
Right. Hi, by the way, I'm Uri. Thank you, Robert, for having me today. And yeah, this is the Wokwi simulator. And on the right side, we chose a pretty complex example. So there is a bunch of connections. There is ESP32 display, LCD display, and a button with the title New Joke. I wonder what it does.
I guess it will say some jokes or something. And on the left, there is software which we will upload to this ESP32, correct?
Right, and there is like you can see right now it's Arduino code, so just a bunch of the familiar setup and loop for people. We can make the font a bit bigger. There is a secret way to do it, to make the font bigger, just for live demos like this.
Okay. Okay, and try play button. I would like to see what will happen. So when you press the play button, you will start the simulation.
Yeah, let's zoom in and let's play. Let's see what happens. So it got an IP address and it loads a joke. Do you get a joke? Let's read it. A programmer puts 2 glasses of his bedside tables before going to sleep. A full one in case he gets thirsty and an empty one in case he doesn't.
Okay.
I've heard better jokes.
And when you press new joke, it will upload new joke.
Yeah.
And it will upload it from a website, correct? I've seen HTTP website somewhere. Yeah.
Right. You can see here, like this is the URL of the API. It just makes an HTTPS request to this URL, and then it loads it as a JSON object. And finally, we get to see like the joke on the screen.
Okay. So now, basically what we did is if we upload this firmware on real ESP32, which is connected like this, then it will work, correct?
Right. I mean, I could show you, but to be honest, I don't even have this screen here, only the ESP32. So, and even if I had a screen, it would like take me 5 minutes just to put all the connections together, and I would probably get something wrong. So yeah, you will have to wait to take my word on that.
Now, my next question is, what kind of boards you support and what kind of peripherals you support in this simulator? And I would like to say you created this simulator, correct?
Right. Created and still working on it. So it's still work in progress, getting better every day.
Okay, let's have a look on what boards you support.
Okay, so the boards, if we go to the home page, there is, actually we can also see it if we go to my projects page, there is a big drop-down menu with all the boards.
Okay, so Arduino, ESP32, Raspberry Pi, Pico, all these like well-known and often used boards. Cool.
Right, and there are also some secret ones in beta that are not listed, but if somebody sends me a message, I might tell them.
It already exists, yeah, okay.
Yeah.
And what kind of peripherals you can connect to these boards? Because this is something what I was like very surprised how many peripherals you have in your library and which can be simulated.
Right, so if we start a new project with the ESP32, for instance, so we get the familiar ESP32, and then we get, let's make the font bigger as before, we get a code on the left side. But then there is this blue plus button, which opens the big menu with everything that you can add. So there is like the basics, LED push buttons, And then there is a bunch of ways to display stuff. So LCDs, OLEDs, LED matrices, 7 segments, and we even got an ePaper. And there is an interesting point about the ePaper I will mention in a bit. And there is like a whole bunch of inputs, switches, joysticks, DAP switches, shift registers, load cells, infrared, encoders, keypad, whatnot. Sensors, of course, to get some input about the environment, motors, servos, buzzer. So there is a bunch of them, even
Wow.
breadboards, micro SD card. And I think my favorite one is the Wokwi logo, which just hangs here. It does nothing. I said that there is something special about the ePaper. So the list that you see here is what we coded into the simulator, but users can also create their own peripherals. And the special thing about this ePaper display is that it was created by a user. He created all the code that simulates this ePaper display and the graphics and everything. So it's one of the first parts in the simulator that was not actually created by us. And maybe this is a good time to talk about this second tab here, diagram.json. So this tab, diagram.
Before we move there, I would like to ask, these peripherals, what you just showed, they have like specific part numbers. So these are real peripherals which you can buy from, I don't know, SparkFun or somewhere. Let's have a look on display, for example. I'm curious about this one.
So yeah, so right. So this is like a ePaper model from Waveshare that you can just order it. And
how do you know the exact part number?
So this is it's super new, so it's not a very good example. But if we take a look, like it's
LCD
the rotary,
or something,
rotary encoder is fine. There is this question mark, and if you click on it, it goes right down the documentation, and the documentation tells you like this is the part number and all the information. Like you have the photo, so it's very easy to check if this like looks the same when you try to order one. And there is like all this information about how it works and the schematics and example code. So even if you are not using the simulator and you're actually getting the physical part, this could be a good guide to how you get started to working with it, how it works.
Can we have a look on LCD display? I'm just curious.
Yes, sure. This
one of these, yeah.
So the TFT one?
No, the standard, yeah, something like
the standard one, yeah.
So there is also info, okay.
Yeah, there is an information and there is like all the P names.
So it's LCD, the part number is LCD1602. Okay, if you search for this, where can you buy it, for example?
Yeah, so if you Google it, for instance, let's do this. So yeah, you can find it like maybe we can just add SparkFun, yeah. So SparkFun, so they have like
C technology,
this basic one. There are like a lot of variants of it, but this is like the basic one. So you have like all the connections here. Here, I think it's upside down because on our parts, the connections are like the other way around, but basically it's the same connections. Here, I think this one has the connections the same way as we do as well. So yeah, the world of electronics is chaotic. There is like a lot of different small variations, and everyone makes up their own versions of the boards with slight differences. That's one of the challenges for people who write simulations and for people who write libraries. But we are trying to make it right in the documentation and explain about the different ways things can work. For instance, for this LCD, you can have it in standard configuration where you use all the pins, those pins to interface with it. Or there is like an I2C version, which only uses 4 pins. So there is like here is like how you connect the standard pins. And if you use the I2C pins, then these are like the pins that you need to connect. And we are even telling you here which chip we are simulating for the I2C controller, because there are a few models in the market. We learned that the hard way. So we try to give you all the information, and if something is missing, you can always go and edit the page on GitHub. It's all hosted on GitHub, and just send us a pull request or open an issue and tell us, hey, I think something is wrong. Please help us.
Okay, and let's have a look also on Servo, because I was very surprised you have their servos.
Yeah, I think Servo is one of my favorites because it's so visual. So you want to look at the documentation, or you want to see it in action?
We can make some action. First, let's start with something simple. Let's start with
yeah, let's take this first example from the
you can click there directly and show the example. Oh, wow.
Right. So yeah, this is an Arduino Uno with a servo, and this time it's black. I think you can, I mentioned diagram.json. So there are like the editor, you can set up like the wiring and add parts, but there are some stuff that you can also edit directly in this JSON file. So if we wanted a red one, we could change the color. So this is like for the advanced users. And then if we start a simulation, we will see the servo going back and forth.
Wow. What is the software? Go to sweep, you know?
What is what?
Yeah, this is what I wanted to see. So it's like...
I think it's one of the examples that comes with Arduino, actually. Just one of the default examples. If you wanted something more fancy, I think my favorite one is this. I call them the dancing servos. So it's 32 servos that are just starting chaotically and then eventually becoming synchronized, going back and forth. And this is something that if you wanted to build in real life, you would have to use a beefy power supply with like just getting all those servos and all the noise it would make. But here in the simulator, it takes like a few minutes to just put together all the connections, and then you can write the code and try different kind of animations.
So basically, this is also interesting point. So when you create software in this simulator, that's the primary goal: create software and simulate the software, correct? And this electronic circuit and visualization in electronics is something what is super helpful, because you can see what the software is doing. But if you really would like to connect it electronically correctly, then you may need to add few more things and be a little bit more careful and do all this electronic circuit properly.
Right. So the focus of the simulator is the software. The idea is that we do have all the peripherals, and the goal is to help you get the software correct. And we take some shortcuts. So if you go back to the sweep example, you see it's working, right? Now, if you build this circuit, it would probably work. The Arduino can probably provide enough amps to drive this servo, unless like it had a lot of load on it. But then, can you guess what would happen as soon as I click on it and delete this wire?
Here in simulation?
I mean, in real life, we know what would happen,
in real life,
right?
yeah, it will not work. But here, I guess it still may work.
Yeah, it's still working. So the simulator doesn't try to be very picky. If the data is there, it will update the parts. The parts are very, they are working on Cosmos power. We still, like in all the examples, we do connect the power pins, because if somebody is copying the circuit, we want them to know. But we don't focus on checking like that we have the power connections and that there are enough amps. So
yeah, it's not electronic simulator, it's software simulator. So
exactly,
you create this circuit, or basically you put there the power because of the visualization. You would like to show it correctly, but it's not really used in simulation.
Exactly, because because what we care about is the software, and the electronics part is only there to support the software.
I understand, but I still think it's like super cool because you don't even need to have the board, and you can test it. Or the other day when we were talking together, I was like, oh, maybe it can be even faster to test something rather than going pick up your board, trying to search for a servo, then connect all the cables. Here you just do like click, 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 and you can test it.
Yeah, or if you are lucky, you can just start with somebody like something like this, where you already have the connection, start from another project and just change the code. So it's even easier. You don't even do the click, click, click. You just have the wiring done for you.
So how difficult it is to create simple circuit? Let's connect LED or something.
Okay, let's do it. So let's assume that we are new users and we come to the homepage, go to the homepage and go to, we are super confident about ourselves. So we are not even going to use the quick start projects at the top. We are just starting from scratch with ESP32. And then let's just make the font a bit bigger for the sake of our audience. And then if we take the very basic project, press play, it says hello ESP32. We see there is like this serial begin, serial println, and a loop with just delay. Let's, for instance, add an LED. What's your favorite color, Robert?
Red is fine, but yeah, we can change. Where did you click to change it? You click on the LED?
Just on the LED, yeah. So red is fine, but which one
green.
do you want?
Okay,
okay, let's do it green. Cool. So that's the LED. Let's add a resistor. Now it will work without a resistor, right? But
again, we would like to be like, if someone is really going to connect these, then they should know they should put the resistor.
Right, and then let's connect this to pin 15.
How do you draw? You just click on the pin and that's it?
Right click and then click on the destination, and I can, oh, what happened here? Click and then click on the destination, and I can even like click in the middle to make it take a different route. And if I press G, it shows a grid, and then I can snap things to grid to have like the lines more nice and stuff like that. So yeah, let's just make this straight line. There is no reason for it to go around. And let's, write some code to, the common Blinky. So let's, for instance, digital write 15 high, delay, let's say 1000. And then we don't need to delete it. And then digital write 15 low and start a simulation, and the LED is going to blink, of course.
Where did you click? I didn't see. How did you?
Oh, to start a simulation?
Compilation.
Yeah, so it's command or control, depending, Mac or Windows, command enter or control enter. It's a keyboard shortcut, but you can also click the play button. It's the same. I'm just so used to working with the keyboard that I sometimes forget that you don't see it.
So basically, when you make any changes in your firmware and when you press play button, it will automatically compile.
Right. I mean, let's change the blinking to be more brief.
Okay.
Play, and now we are compiling. It's actually compiling it on a remote server. Takes a few seconds, and now we can see like the blinks has changed. Like there is like this brief blinking pattern.
Okay. Let's make a little bit more complicated example. We are going to add button.
Yeah, let's add a push button. And we can add it, let's say, to pin D14 and to ground and make it pin 14 input pull up. And then let's say, what do you want to do? Let's just make a counter. So whenever you click the button, it will increment the count. And then if digital read for 14, if it's slow, so it's pressed, then let's say count plus plus, counter plus plus, and let's wait until it's like they stop pressing on it. So let's wait, not quite while.
So this is the bouncing, basically.
Not even the bouncing, just waiting for to pick the big finger from the button, because as long as you are pressing on it.
Oh, okay, I understand.
Yeah,
okay,
let's also yeah, let's also make like the LED go high while you are pressing the button, so it will be easier to see it. So we'll both go high while you are pressing the button, and we will counter, and we'll also digital write. Serial print.
Yeah, okay, we will print on serial console.
Yeah, let's print the counter. Okay, and let's start the simulation. And what happens? It compiles. And are we ready? Will it work? What do you say?
I don't know.
It compiled successfully. Let's click and see what happened. Oh, what is that? I think I had a bug, right? We have to wait while it's still low, not to wait, or wait until it's high, not to, otherwise it never gets into the loop, because we just entered the if it was low. So yeah, let's try again. And now when I click it, oops, something interesting happens. Whenever I click it, we can see that like...
So this is the bouncing feature.
Oh, you got it right. Yeah, so this is where I get every week somebody asks me, hey, there is a bug in the simulator. Like I pressed it once. Why am I seeing so many clicks? And the reason for this is this little checkbox. So by default, when you add a button, we are simulating bouncing, which means whenever you click on them, we're actually opening and closing the contact a few times to simulate physical buttons. If we uncheck this box and restart the simulation, we can now see that every click just has one. Now it works. But don't do this, because this is like not the correct way to do it. The correct way to do it is to make sure that your code deals with bouncing. Like I think one very easy workaround will just be to add a delay here. It will probably fix most of the bouncing. Yeah, maybe another one here, just to make sure that when you leave it, there is another pulse. So now if we restart the simulation, did we enable bouncing? I don't remember. Yeah, let's stop it. See, yeah, it's bouncing. So now if we start a simulation, we can click on the button and we see like that our code will work with a real button, because we had a pretty simple, but it usually works way to deal with the bouncing. And while the button is pressed, the LED is on. When it's depressed, the LED is off.
Can we switch on the LED through serial port?
Yeah, of course. So let's add, so we have this button to support the LED. Let's add a second LED to make it more interesting. So click and deduplicates the LED. Let's make it blue this time and connect it to, let's say, no, I won't. You will forgive me for skipping the resistor here, right? You will, please?
Maybe we could put there one. So it's
you want, okay, you want forgive. I tried. Okay, so let's put in, oh, yeah, we have to fix this. It's the position of the question mark is not good when you rotate the resistor. Yeah, let's put it here, pin number 2. Let's give this wire another color so it's easy to understand what's going on here. And let's connect the ground as well. So now we have pin number 2 output, right? And then we can do something like this, serial input. We are reading from serial, let's say read string until there is a new line. So reading one line at a time. And then if serial input dot index of, so if the serial input, like the string that we read from the user, contains the string on, then we digital write to hi. And
there is
not,
mistake.
yeah, it's not dictail, it's digital, worry. And yeah, obviously, if this was production code, you wouldn't use 2, you would actually get a constant for the LED number.
Yeah. But this is just for
but you can forgive me, right?
Yeah,
Please
of course.
Forgive me. Okay, so now we need, I think it will work. Let's see. Let's first cross our fingers that this compiles. And if it compiles, we can start giving it commands like, hey, turn on.
Huh.
Yay. Hey, please turn off now. And yeah, it turned off. So yeah, so we can even interact with the serial console. Now, I think one of the things that is really powerful here, we talked about the bouncing of the button, right? And now it doesn't work because it's waiting for the serial input. But we talked about the bouncing of the button, and you had to believe me, it was there. Like we have seen like the program behaving differently, right? But how can you actually see the bouncing of the button? Do you have any idea how to do this?
You have some kind of probe.
Right. So there is this logic analyzer, which you can connect, and there is like 8 input pins. And if we connected, let's say, pin number 0 to the button and run the simulation again, yeah, when we press the button, we can see like there is a number of samples that has gone, like there has been a few changes on this line, on this signal. And when we left the button again, and then if we stop, when we stop the simulation, we actually get a file, a VCD file, and that's a file with a recording of the signals that we can open in software like PulseView. So PulseView is unrelated to Wokwi, a free software, and it allows you to see signals. So at the beginning, this is when the simulation started. At this point, when we zoomed in, the transition was very smooth. This is like this line when we turn this button into a pull-up.
Enabled pull-up, yeah.
Yeah, and this is when we click
when we
the
press
button.
the button, yeah, because you connect it to low.
Exactly, and this is when we left the button, we released it, right?
Mm-hmm.
Like we can actually see how much time it was pressed. It was pressed for 6.1 simulation seconds.
Mm-hmm.
But the interesting part is when you zoom in, you can actually see the bouncing, the simulated bouncing. So we can actually see how long the bouncing took place, and almost 2 milliseconds, and like the actual pattern of the bouncing. And we can see that there was another here. When we released the button, there was a lot more bouncing. So it's the simulator just simulates at some randomness, so you wouldn't get the same bouncing pattern every time. And you can use this method like to actually understand what's going on inside the simulation. For instance,
can we connect this to UART? I'm very...
Yeah, exactly. We can connect it to the UART, to the TX and to the RX. And let's connect, for instance, another one to the LED, so we can also see the input and the output. And let's make it blue, like the color of the LED. And then if we start a simulation and we press say, hey, on, now off. Then when we stop the simulation, we get the same recording. And we will be able to see like, so we said the first one was the TX, then there was this RX and the LED. So we can see like, if we zoom in here, we can see like these two messages that we send on the RX line and the LED going on, then the LED going off after the second message. And if we zoom in further, we can see the actual like protocol. But I'm not very good at, I don't have this superhuman ability to just look at protocols and tell what the text here.
Sorry for interrupting. Should not this be on TX?
Oh no, because it's from the perspective of the ESP32,
Okay.
not of the serial terminal.
Okay. Okay, I mean, so let's, what you were saying, we can actually decode this information?
Right, so PulseView, for instance, has these decoders where you can just tell, hey, I have UART here, and it goes on the RX and TX pins, and it will decode the information. And we can even ask it to show it instead of like hexadecimal numbers in ASCII. So if we run it again, we can see the text that we sent. Hey, on.
You know how much time you can spend doing this on real hardware, and if it doesn't work?
Believe me, I know. Like building a simulator, I had to do a lot of tests with real hardware, and I can imagine like, yeah, it's like you don't know how many times a day I have to take the logic analyzer when I adding a new simulation model of a new like part. I have to take the logic analyzer and compare it with the signals that I see in the simulator. So I'm actually using this very method to debug the simulator itself to make sure that like we simulate the protocols correctly and that we have like I think the SD card was, for instance, very challenging. If you run a simulation with the SD card and you then connect it to this virtual logic analyzer, you can see there is tons of data being sent back and forth. And without using stuff like tools like this, it would have been a nightmare to debug. Like there is millions of edges on the signals that you have to take into account. And if you don't have those decoders where you can actually see the data, it's just a big headache.
So you also have SD card in between your components?
Yep. We can actually, I mean, there are a few examples. Let's see if there is a good one in the demo. So yeah, the demos don't really have very amazing examples. Like this just prints the files on the SD card.
Mm-hmm.
But yeah, you can see it here. And we used to be, let's see, maybe I liked it. I hope I did. There used to be like somebody read, oh yeah, thanks to past me that I liked this project, so I could now find it fast. So there is a way to upload files to the SD card. That's one of the smaller or the smaller group of features that are actually paid. So if you want to upload your own binaries to the SD card, you have to join the Wokwi club with this.
Okay, let's talk about this. So let's talk about pricing, because I know for a lot of things it's like completely free. Only like some very special features are paid. So let's have a look. What is basically free and what is paid, and how much does it cost?
Good question. So everything you have seen up to this point is totally free. This is the first thing that actually costs something if you want to upload files to the SD card. So if we start this example, it just loads the JPEG files from the SD card and throws them on the screen.
Unbelievable.
It does, yeah. So let's say if you wanted to just take this example and run it as is, or change the code, you could still use the free version as long as like somebody else already uploaded the files. But if you wanted to add your own JPEGs into the SD card, then you would have to pay. And just to make my case here, if we added the logic analyzer here, and I don't think we even need to look at the signals, just connect the SDK and the data in, data out. And I want you to notice the number here of how many samples it's recording when we start a simulation. Like, you see how fast it got to 1 million samples even before we started drawing. And the reason it stops at 1 million samples by default is because storing those samples in memory takes a lot of memory, and we don't want to blow up the browser. But just imagine if, like, in 2 seconds it got to 1 million, then by the time you display the JPEG, it's like, I don't know, 20, 30 millions of signal transitions that has to be, every single one has to be right for this to work. So that's why I'm really grateful to have all these tools inside the simulator and PulseView to be able to debug it when I'm building it.
Let's go back to the prices. I'm curious.
Yeah, so the quickest way to go is just wokwi.com/club, and let's go over the list. So yeah, we have seen that you can upload custom files to the SD card. The other thing that you get if you join is you can upload your own libraries. So when you write a project, let's say we have this project that we created here, there is this library manager, and you can use any existing Arduino library. So I don't know, you want DHT, so you have like all those DHT libraries.
This
like
is what I actually used.
Oh, you actually tried it with the DHT?
30, I think it was like 30 or something.
Yeah, or if you type just Adafruit, you will see that they just spammed the library list. They have so many libraries. I guess it's the same for like SparkFun and others. So this is like still free. Like if I added this, I don't know, DHT22 library, you can see it's on the list. It's also in this file, and this is free. But if I wanted to upload my own custom library, maybe something I downloaded from GitHub or customized, then that's in the paid plan. And still, if somebody else, like I uploaded it, saved the project, shared the link, and somebody else run it on their computer, it's free. Only uploading the library is what is costs money. And then I think one of the features that I really love is the ESP32 Wi-Fi. So we have seen like a quick demo of it here with the jokes. And as I said before, you can
even simulate the Wi-Fi connection.
Yes. And like I said before, like this is free. What you have seen up to now is free. So just simulating the Wi-Fi is free, but there are some advanced features that cost money. So one of those features is letting you, or maybe let's take one step back and explain how the Wi-Fi works, because when I run this simulation, we are actually making a request to a server in the web, right? This jokes API. And this is an HTTP request. So you could say maybe the browser is making this another HTTP request, because browsers can make HTTP requests. So maybe this is how it works. But let's see another example where
we can control LEDs through website, for example.
Yeah, that's a good one. But even before that, I wanted to show something even simpler. If we go to ESP32 Wi-Fi, so there is this, for instance, very simple NTP client. So it just connects to NTP. NTP is Network Time Protocol server. It's connected to the NTP, gets the current time, and it prints it on this LCD. Let's start the simulation. And you see it's connecting to the virtual Wi-Fi, and it's updating the time, right? And now it's no longer an HTTP connection. It's a different protocol that isn't supported by the browser. Browsers can't really do NTP connections. So how does that work? And the answer is that we are running a spatial gateway in the cloud that talks to the simulator, and it forwards all the network requests from the simulator to the internet. So that's how the simulation is connected to the internet. And one way to see that and to understand what's going on behind the scenes when you run a Wi-Fi simulation is to, if you press F1 in the code editor, it gets you to the secret commands menu. And I hope that in the future we'll have an easier way to do it. But when you go to the secrets command menu and you can download Wi-Fi packet capture, and when we download this file, it downloads this pickup file. We can open it with another software called Wireshark, and we can see all the virtual Wi-Fi communication that happened. So we can see all like this virtual access point, Wokwi guest that we have inside the simulator, and we can see this expressive chip talking to it and connecting to it. And it's then sending a DHCP request to get an IP address in the simulated network. And it's get an IP address from our virtual gateway. And then we can see like, eventually it will make a DNS request. It asks the DNS server, what's the IP address for pol.ntp.org? And it gets this response with those IP addresses. And then it sends the request and the response. So it's also very useful if you are developing something that talks to the network, NTP, MQTT, HTTP, whatever. It doesn't work the way you want it to work. This is very useful to
you can have
see
a
the
look.
traffic. Exactly, you can have a look, like see
Where
everything that goes. Exactly. And the reason I wanted to show you this to you and the people watching this is because this is the level we simulate the Wi-Fi. We actually simulate all the data that would have been in the air in the real chip, and all like the protocols and everything. And then we have this gateway that connects you with the real internet. And the free users are using our cloud gateway, which is working, but it's a bit slower. And we have logs of the communication. So if somebody is doing something bad, we can trace them and track down their accounts and close it. Then if you are joining the Wokwi Club and paying, you can also run this gateway on your computer. And this means that all the traffic goes directly from your computer, so you can connect to other devices on your network and not just to things on the internet.
On internet. Okay, I understand.
Exactly.
So basically, you still can do a lot of Wi-Fi things even for free. Can you control the LED in the free option?
So if you wanted to do something that controls an LED from the web, you would have to use something like MQTT in the free version. We actually have an example because you asked, I will show it. So this is something you can also do in the free version. This is doing the opposite, but it's still the same idea. So this is ESP32 connected to DHT22, temperature sensor that we all love. And let's make the font bigger. So this time it's not even an Arduino project. So this is a MicroPython project running on the ESP32, and it connects to an MQTT server. Let's open their web client. So let's put it side by side. This is the MQTT, and this is...
So you can read the sensor value?
Exactly. And I have another demo. If you want, I can send the link later to share with the viewers, where you can do the opposite, like control LEDs from MQTT.
Yeah, we can open it because I've seen when we had the call last time, I think you used LED example then. But let's do this first.
Yeah, let's do this. So here is the client. Let's start it. Start a simulation. It will connect to the virtual Wi-Fi, get an IP address, and now it's sending the data to the MQTT server. And here, let's say, let's see the instructions because I don't remember. Let's connect to the MQTT from this web client. And we don't want to publish, we want to subscribe. We want to subscribe to this Wokwi weather topic. And now we should see that whenever we make changes to the temperature, we can see them immediately appearing in the MQTT server. So whenever there is like a change in the conditions,
so basically, if you would like to control the variables in the sensor, you selected the sensor and you use the slide bar to change it?
Yeah. If you want to change anything in the sensor, just click on it, or other parts also supports like also support configuration. Just click on it. Some of the like let's say there is like this joystick. So some of the parts can even be manipulated directly. Like if you wanted to move the joystick, we just click on the joystick itself. But for sensors that don't have like a very obvious input mechanism, just clicking on them when the simulation is running, lets you change the values. And then we can like report them to MQTT from this MicroPython script. And
wow, really, like I'm very surprised you simulate all these things.
Thanks. So yeah, I mean, the simulator itself doesn't really think about what it's simulating. It's just trying to simulate the ESP32 microcontroller and just execute the binary files, the firmware files, one instruction at a time, and all the peripherals like UART, SPI, and etc. But yeah, it takes a lot of work to make it so that you click play and behind the scenes, what happens is this code, this MicroPython code, is actually written into a virtual file system on the flash of the. I mean, I think we can probably see it if we just Control C and get into the MicroPython prompt, and then
because there must be something already running on the ESP32.
So it's running the MicroPython firmware, and if you look at the OS list there, it actually creates a file system in the like so. It starts with the MicroPython firmware, and then next to it in the flash, it actually creates a file system, and then it uploads all the source code of the project into this file system. So don't remember. The exact, yeah, we can see like the free space and stuff. It's not very useful. It's not very easy to see on MicroPython like what those values means, but there is actual file system simulated inside, and it has your source code. So when you press play, you don't have to do anything. Wokwi
you don't have to flash, you don't need to do anything. It will just start running.
Yeah, but it is as real as the
I understand.
yeah, as
this can also save a lot of time, because some of the boards, sometimes they don't want to connect, and you try to figure out how to flash it, and if you just use this simulator, it's just much faster.
Yeah, I think one of my first experiences with the ESP32 with the board when I started working with it was trying to upload a firmware to it, and I specified the wrong offset, and then I overrode the partition table or the bootloader, and I was absolutely sure I bricked it. Like it took me an hour to find the right command to write and to download, find a new bootloader, and like figure it all out. And I was really freaked out. Like it's a new board. I just bricked it. It's yeah. I mean, with some of the newer boards, it's so much easier. Like the Raspberry Pi Pico, you don't have to do all this like command line stuff to flash it. You just download a UF2 file. But even then, I mean, we are trying to make Wokwi as simple as just clicking at the button and it works.
Okay.
If you know how to write a code, that's where most of the problems, like most of the users get confused, where they have to find the bugs that they have in the codes. I mean, actually, another cool demo that if we're already in the MicroPython that I can do here, if we connect an LED to this. I think this shows really well. And this time you will have to forgive me for not
No
adding the
resistor.
resistor. Yes, you forgave me. Thank you. So we added this LED to D2. And this is something that I will be honest, I don't remember. I just looked it up while we were chatting here. So let's make the font a bit bigger so it's easier to see here. So I'm going to do this. I'm going to use the low-level API of MicroPython to write to a specific memory address. And this memory address is actually the memory address of the GPIO peripheral in ESP32. So I'm writing directly to the memory of the GPIO peripheral. And this is like the pin enable. So I'm now the output enable. So I now made this an output pin. And now I'm going to turn this on by writing to the GPIO out register. Are you ready? Let's see if it works. Yes. So yeah, you can actually manipulate
on like a very low level.
Yeah, because we don't, the simulator doesn't really know what it's simulating. It's just running instructions. So even if you call the high-level API of MicroPython to toggle the LED or of Arduino, eventually this translates down to
these
a write.
instructions.
Exactly. So this also means that you can just send these instructions directly or write assembly code in Arduino, or even there is a way to write assembly code in MicroPython on ARM target. So you can even write assembly code and that would work. I mean, there are people who actually wrote a complete game in AVR assembly and it works in the simulator because the simulator just runs instructions. It doesn't care what language you use. There is also the Rust programming language. So I'm not really up in the game of Rust, but there are a lot of people that are starting to use Rust for embedded development. So if you go to wokwi.com/Rust, you can see a bunch of code examples with this new programming language called Rust. And
I have never used this.
Yeah, I mean, I'm not a big, like, I know a bit of Rust. I'm not very big on this, but yeah, I mean, the fact that people are doing it with Wokwi now, it's amazing to see like how this community takes the simulator and starts using it to their development, to developing Rust on the ESP32 chips. They are actually using, so Wokwi is available in the browser, but there is also Wokwi for Visual Studio Code. So you can use it as an extension for Visual Studio Code and run the simulation from your code editor. So people who are working on Rust for ESP32 are just using Wokwi to create a lot of examples and to evolve Rust and ESP32 to work better together. So yeah, sorry, I was just sidestepping after we talked about Python and
Okay,
yeah.
so now I'm curious about the controlling LED over internet. Can we find this example?
So yeah, so we can do it over MQTT. Let's see if I have it. I think I have it from another talk that I did. Let's see if I can really quickly find it.
I would like to show this example because it can be something what people use, or they would like to control something over website.
So I have this example, which is similar to what we saw with the DHT22. So basically a LED ring with ESP32 and MicroPython code. And then you need to send a specific message to set a color. So let's say we want, what's your favorite color? You said green, right?
You
can change it if you want. You know what? Give me just 3 numbers, RGB.
Okay, put there 02550.
Okay, so you went for green. And as soon as we publish it, you can see this is received in the simulator. And yeah, I prefer, sorry, but I prefer purple. So let's take it purple. Yeah, and if somebody's actually watching this online right now and they will be real quick to go to this website, they can actually change this as we are simulating. And we can do exactly as before. We can download this packet capture and see the actual traffic that went into the simulator. Like we can see that it subscribed to this topic of Wokwi, and that it got 3 messages like this 2550255. Yeah, those 2 messages that we sent.
Can you run a web server directly on ESP32 in this simulator?
I hoped you would ask. So yeah, so now we are finally getting to a paid feature. This is a feature that, I mean, you can run it even on the free version, but if you want to connect to it, then you need to run the internet gateway on your computer. Let me just close a few tabs because it's freaking me to have so many open tabs. ESP32.
And I would like to point out, even when we are talking about paid features, I don't want people to think like we are doing advertisement or something, because I can clearly see that you put these paid features on the things which require extra storage or extra resources, which you need to pay probably, I guess.
Right. I mean, it's the cost of resources, and also like the things that are more complicated, and then users are having problems with that, and we have to support them. So if a lot of users are going to use those advanced networking features, we have to spend a lot of time supporting them. So
and also you need to live from something and support this project from something.
Of course, I mean, we want the Wokwi to continue, right? So yeah. So that's a good point. Thanks for mentioning that. And so back to your question, can you run in a web server? Yes, you can do it. You can even do it for free. But if you want to connect to the web server from outside the simulation, then that's where you need the paid IoT gateway. And let's just see it in action. So this is another Arduino code. You can see there is like some web page it's going to send us, and it's going to connect again to the virtual Wokwi Wi-Fi. And if we run the simulation, we see that it's connected to the Wi-Fi. It got an IP address and started HTTP server. And we can open this link in another tab. So I want you to notice that, yeah. So this is the ESP32. This is going to localhost. And the reason it's going to localhost is because this ESP32 doesn't really have an IP on my local network. But I'm running the IoT gateway on my computer, and it has this IP address in the virtual network of the simulator. And the IoT gateway program that I'm running on my computer is forwarding this port 2080 into port 80 in the ESP32.
Yeah, I understand. Yeah.
Yeah, so there is a lot going on behind the scenes, so this just works. But what this means, you can go to localhost 2080, and whatever you do here, just
2080 or 9080?
9080. I'm really good with, really bad with numbers when it comes to English. I always mess them up. So please bear with me. So yeah, 9080. So localhost 9080, just get redirected inside the simulation to port 80. You can also like configure it. Like the IoT gateway is just binary that you can download and run. And there is like parameters that you can tell it to port additional ports or for different ports. So yeah, so there you go.
Okay,
HTTP
so if
server.
I understand right, from your simulator, you are sending this data through this 9080 port to your router, and in your router you have to set forwarding rule from this 9080 port to port 80 on the computer where you are running this simulator.
let's just the word router, when people think about it, they think about the physical router of their network, but it's like a virtual router that is actually a program that is running on my computer.
Okay.
So everything here happens in my computer. This goes to the I call it a gateway, the IoT gateway. It's called the IoT gateway, so it's going into a program running on my computer.
What
that
program?
listens. It's called the Wokwi IoT Gateway. Let me open the
So if
GitHub
someone
page.
would like to use this feature, they need to install it, correct?
Right, they need to download it. It's here is the GitHub page for it. So they just need to go to GitHub releases, get the latest release, download the binary for their operating system, and run it on their computer. And that's what you need to do to have like all this set up on your computer. If you don't do it or use the free version of Wokwi, then it just goes through the Wokwi cloud, and we do this for you. Like this is also this is very similar to the code that we are running in the cloud. And this is actually open source, so you can, if you are curious, you can actually see the source code and compile it yourself. You don't have to trust us. I mean, I wouldn't trust somebody random.
Yeah, I was thinking about this, like, because I'm like super careful about installing any software on my computer.
I know. So that's one of the reasons why I wanted this to be open source, so people
know that you are not installing, or you are not putting there something else.
Yeah, and I mean, the second thing is that this is also like part of the paid version, like running this gateway on your computer. So, I mean, there is no reason for me to do anything harmful for you. You are paying me, you're my client. I want you to be happy. So that's another thing. But other than that, it's also like this gateway is open on GitHub, so people can compile it themselves if, I don't know, the operating system is not supported, or if they find a bug and want to fix it, or if they are not happy with the default port forwarding or whatever. Like it's totally open. And yeah, this is like the glue that makes it possible for the simulation running in the browser to connect with the outside world. And in this case, for the outside world, also to connect to the simulation.
Okay, we can go back. Okay, so what else are the paid features? And I think we need to also say it's $7 per month, correct? That's what I've seen. That's the
right. This is the price for the club. This is probably I think there is one more feature when you save a project. So
oh, I've seen it. It was a private project. Okay.
Yeah, we had this new cool project that we created, and when we save it, it says, hey, what's the project name? ESP32 link, UART button stuff. And then if you want to make it unlisted, then you have to be a club member. Otherwise, it's just public. It appears on your profile. And our motivation here is to help other people share. Like, yeah, we want people to share what they are doing. So that's the default. And if you have a reason to keep it unlisted, then you can join the Wokwi Club.
Okay. So it was next. So keep your private project unlisted, get any feature that you want. So I guess
with an asterisk, yeah.
Yeah, okay.
So this is something very unique. I don't think I've seen it anywhere, but tell me if you did. There is this page where people can suggest new features or ask for future features, and they can vote for them. And what's unique about that is that the way to vote for features is to get vote powers. You can either buy them, or if you join the Wokwi Club, you get, I think, 10 or something like that every month. And then you can, people who are supporting Wokwi can actually decide what we are working on, help us like see what's important to them, so we can implement them. And you can see that right now the number one thing that we are working on is multiple MCUs. So if you wanted to put two ESP32s or Arduino and ESP32 together, currently Wokwi can't handle this, but it will soon, thanks to many people who voted for it.
But create new parts, you already mentioned this works.
Yes. So
the second one.
The second one is the way we are working on stuff. We are looking at the list, and whatever something is coming up to the top, we start planning and working on it, because it takes time to iterate on things like this. Create parts chips. So each item on this list is actually an issue on GitHub. If you click on it, you can go to the issue on GitHub. You can see when it was suggested, all the comments that people left, all the progress of the implementation. So you can see that there is, back in July last year, in July, there was already a first prototype of this, and it's something that is
so
evolving.
Many of these features, they may be already in progress. They are maybe in beta testing or something, and it's not like you would be only working on one feature.
Right. I mean, creating a feature takes a lot of work. For instance, if we check number 7 here, Raspberry Pi Pico W, which is Pi Pico with Wi-Fi. This was suggested not too long ago, November 22, and it also got to place number 7. And you can see, like, a few months later, I saw it's getting votes, so I did some initial research and wrote my my findings. And last week, I actually ordered a physical chip to get it to start working on the implementation, and found this blog post with useful information. So it's progress. We have to create like the simulation module, and then we have to create the graphics, and then we have to create the documentation and examples, and start testing it and documenting what works, what doesn't work. So if you, for instance,
do you work full time on this, or you have also a different job, or?
If you asked me that like a year ago, I would say yes, I'm working full time on this. Now it's not only me, it's also my life partner Ariella who is working on it. But there is also another interesting project which I would happy to discuss another time, that is called Tiny Tapeout. And in just one sentence, it lets people create chip designs. So Verilog, or even there is a way to do it graphically with Wokwi, and have their design manufactured on a real chip for like $100. So you get a physical chip with your digital design on it, mounted on a PCB that you can test for $100. But let's leave it for other time, because it's a big story for itself. But
I ask because I'm curious, like,
how
do I make
living?
How you make money exactly?
So it's a combination of other projects that I worked on in the past, and they are still generating revenue, and that allows me, gives us the runway to work on Wokwi. And actually, we have a few hundred of club members already, so it's slowly getting traction. And we hope that, I don't know if by the end of the year, maybe by the end of next year, but we hope that at some point Wokwi will be able to sustain us. So the future of Wokwi will be promised. We are also looking at Wokwi for classrooms. So
you definitely should go to schools with this, because I think this is like super cool. Like schools, they don't really. For schools, it would be super fast, because I can imagine if they have limited time to build circuit, then they could very easily use this simulator, design the circuit, build it, and then next time when they have next hour or something, they could physically build the circuit. I can really see this in schools, definitely.
Yeah, I mean, schools are using Wokwi, and the funny thing is that we are learning about it sometimes even from, like, let me show you this. I mean, I found it last week and this news article, and I was like, wow, it happened and I didn't know about it. Student from SMK Arang Road won the Arduino online simulator Wokwi challenge. We never held a Wokwi challenge, so I was like, what is that? And then I looked into the details, and it seems like there is IEEE Sarawak subsection that organized this challenge. And whoa, IEEE organized a challenge, and I didn't know about that. So, and students were given 5 months to complete a project set up in Wokwi simulation, and I was like, it happened for 5 months, and I had no idea. I was so like, wow, luckily I at least found the article about the prize, because otherwise it would have happened and I didn't know. So yeah, I'm doing a really bad job at understanding who is using Wokwi and how it's being used. I know there are a lot of schools and universities that are using Wokwi, and I'm in touch with a few, and I hope to eventually figure out a good set of features that will be useful for classrooms, and also have like some kind of classroom package for universities and for schools.
Mm-hmm.
I mean, one of the problems, or it's not a problem, one of the good things about Wokwi is that the free version is really, really useful. So people just use the free version and they enjoy it, and they don't even tell me. So this is how I learn about this kind of things.
Okay, let's have a look on some more interesting examples of what you can build here. I think you have some games or something in these examples. Let's have a look on some games.
There are some good games. Let's see if I mean, there are like the games on the homepage. I think the Simon game is pretty nice.
So Simon game is you need to repeat pattern.
Right.
Guess, yeah.
You need to repeat it.
So you was like green, blue, green, and you need to.
Yeah, and you can't really. I think you can't really hear the sound because it's going through my earphones. But there is also sound here, which makes it interesting.
Easier.
Let's see if you can hear it. If I pull it next to the microphone, I'm going to fail now. Let's see if you can hear it.
No, I think Zoom will filter this.
Yeah,
because Zoom will think it's a noise or something.
Okay, this is homework for the people who are viewing it.
They can try.
Go and fail and see what the sound is like.
Actually, I played this. I played this one.
You know the sound.
No, yeah, because before we had our first call, I had a look on their website, and this is one of the games I played.
That's amazing. So you already know it. I want to show you something that's...
Something with display. Show me something with display. I tried Pong, or what was there?
Yeah, I just wanted to show you something that is not really public. I mean, people know about it, but it's not, you can't find it from the homepage. So something we experimented with is Verilog support in Wokwi. So this is like the same game implemented in Verilog, same logic.
What board are you using for this?
Can you repeat the question? So
what board you are using for this?
So it's not really using a board. What it's using, maybe let's take a step back. I just jumped into the water to show Verilog, but so this is the part of these features which allows people to create new parts, chips, and sensors with custom logic. And I sort of briefly mentioned it at the beginning when we talked about this. That was the ePaper. So ePaper, yeah. So this ePaper that somebody created. So the way this works, people can create their own simulation modules in C++ or in C, sorry, we call them chips. If we go back to the documentation, we can see a very simple example. That's in the chips API getting started. We can see a bunch of examples, like I think one of my favorite examples, because it's simple, is how you create XOR gate. So this is a Wokwi chip that somebody created, and you can see there is like this logic in C. it does a lot of stuff like initialize pins and watches for changes on the input pins. And then this is like this line is the interesting. This is where the calculations happen, X or B. So it reads the input, reads the other input, and then sorts them, and then writes the output.
It is like the structure is almost like Verilog or this kind of things I see. And at the beginning, you specify the pins which are in the module, basically, and then you specify,
Yeah, so this is a very simple chip, and the idea is to let you just extend Wokwi with custom sensors. So there is like, I think, this digital temperature sensor, which is another, like, it's a big longer chip, but it just does all the calculations, and it has like registers. It implements an I2C device, if I remember correctly.
Yes.
Yeah, and then you can like set the temperature, and it just works. But behind the scenes, this is like running this code in the simulator to simulate this chip, and it also runs this code on the simulated Arduino to talk to the simulated chip. So it's like having both the chip and the program that talks to it here. Yeah, you can see here like the initialization of the I2C slave inside this chip. And this is still a new feature. It's not like something that we have, it's still in beta, and people are using it to create very cool things. And while I was working on it, I had the same realization as you, that it's in a way very similar to Verilog. So maybe we can even use Verilog to describe those custom chips. And what you're seeing here, this Simon game, is one of my first attempts to take that into play. So this is actually a custom chip for Wokwi that is written in Verilog. Yeah, behind the scenes, we are actually compiling this code into code in C, similar to this. So we are using Yossi's CXS RTL to compile this into C and add some wrapping around so it works with Wokwi. Wokwi doesn't really know it's Verilog. It thinks it's C code, and there is a lot going on behind the scenes.
I understand. I don't understand. So basically, you can create modules which will describe the feature in Verilog. It will be like your own small FPGA board, and then you can connect there all the other peripherals.
Exactly. Or you can do it in C if you want. Like, I think this is one good example, because the chip actually implements a display. So it's a display board that we don't have in Wokwi, but this was one of the more complex demos I created with the chips. It just implements this display chip controller, and it lets you see on your screen like whatever is sent from the Arduino. So if there is some unique LCD that you don't have yet in Wokwi, you can implement it as a custom chip. And you even have these existing examples. That's how the person who created the ePaper display, that's how he did it, just creating this custom chip. And I think by far the most amazing example I've seen of somebody who created a custom chip so far was this one. They took this interface where custom chips can like we have here, where they have this portion they can draw on, this display part, and they created a scope. So this is actually a custom chip. You can see the source code here. This is a custom chip that some very talented person wrote. And this is a full scope, like it has support for this, like you see, this is the second signal here.
Yeah. So basically, in Arduino, you are running some code, and output from this code is sent to this scope. So the first channel is something, second channel is the analog.
Right. I think this is like there. It also added here another chip that generates signals. Yeah, I think that's like those. You see this like. Let's let's zoom out. So this is the sinus, because you couldn't generate that with Arduino. Unless you added some capacitors, but we don't simulate capacitors. But if you need to simulate capacitors, then maybe you can use a custom chip for this purpose. So yeah, so I think the Arduino is like this one and this one are coming from the Arduino, the top two ones, and then this one, the bottom one, is coming from the signal generator, and the second one is coming from this potentiometer.
So you can basically take this and use it also in your own project to see the signals without exporting the file which you showed in the first example.
Right. And this was the first time that a user showed me a better way to do something that we already have in Wokwi, this logic analyzer, and showed me, like, he sent me this like 2 weeks ago on the Discord. We have a Discord chat. He sent it to me and I was like, wow, man, you nailed it. It's so much better than what we have now. And I'm planning to have something like that probably over the next few weeks in the add part menu, just like we added the ePaper.
Okay, it's not in this library right now.
No, you see, it's like coming from this project, those files. So if you wanted to copy it to your project, you would have to copy the source code for those two files. But now that we have it, we are going to add it like we did with the ePaper, yeah, and with a few other. Let's see if I can find just an example for the ePaper, because I think that the person who worked on that did really good job with. Yeah, let's see if I can quickly find an example. I mean, he deserves to be highlighted here. His name is, by the way, Bonnie, and it's so amazing to see how users are doing this cool stuff with the simulator. Yeah, I can't find it right now, but yeah, sorry, Bonnie. So I will have to. Oh wait, I found something he sent me while he was working on this. So this is like him debugging the ePaper before it went into the add part menu. So before it, we added it. That's like the older version. The newer version actually simulates like the screen flickering when you are
updating it.
Yeah, when you are updating it, and it's like
this is super useful. You know how much time I spent actually when I wanted to make this ePaper work, like.
I know. I could show you over there. I had my own. Oh yeah, this. I don't know how I missed it. This is the repository, so it probably has a link to an example somewhere here. Yeah. Yeah. Oh, Bonnie, you got a link wrong. You got a link wrong. Too bad. Yeah, I hope that you would have the link, but it seems like you messed it up. Anyway, so yeah, you can just go to his GitHub and ask him for a link to.
Maybe he will update it when you tell him.
Yeah, I will tell him that he needs to fix it, because otherwise he would have seen these cool things if he updated it. But yeah, he did an amazing job here. Like if you look at the code, it's like I think overall a few files that he did over 1,000 lines of code total just to implement this ePaper display. So I was amazed when I saw it working. Like, wow, heads off, Bunny.
Super cool. I need to be honest. I told you already when before we actually spoke first time together, and I've seen that we are going to talk about simulator. I was like, oh, I've seen so many simulators, and they are all the same. And then when you showed me this, I was like, wow, that's definitely not something what I was expecting. So many peripherals, even like Wi-Fi is supported. You can create your own components. Like you can probe the signals. You can see the signals. I was very, very surprised.
Thank you. Yeah. I mean, I usually don't get to show the simulator like this, so it just hits me now how many like things we shown today and we talked about today. And here I found the example from Bonnie, like that uses the final version of his screen. So now you can see it's like flickering before displays, and
So this is the black, white, and red.
Yeah, the black, white, red version. That's I think you simulated both, so you can see it like doing all those flickering when it changes the screen. And this is like the fast refresh mode. So yeah, so I think you still haven't finished working on it, but it's already useful, so we included it. And I hope that soon we will also add this question mark with link to documentation, so people can actually have easier time finding the examples than we had today. And, you know, I just figured out we missed one very important feature. We always showed what happens when the simulation is running, but what happens when you pause the simulation?
Oh, you can see how all the pins are configured.
Right, you can see every single pin on your microcontroller, the state, like its input, output, high, low. And if it's like configured as a peripheral, like here we is using the SPI, you can see like the configuration. And with boards like the Mega, it's, I mean, the peripherals are pretty constant, like they don't move around pins. But on the Pico, we just had an example today where somebody sent me a project that didn't work because the peripheral was coming out on different pins, used the SPI and different pins than he thought. So we wired it incorrectly. So
you could immediately see that the peripheral is connected to a wrong pin, or pin is not configured properly for the feature which should be there.
Exactly. I mean, whenever I get a bug report from users, and that happens all the time, most of the times it's just like they do something and it doesn't work. And if it's not a problem with the code, which is always almost always the problem, then it's almost always a problem with the connections. And up until we added this, I had to connect the logic analyzer to the pins to see if there is any signal going on them, and if to try to understand if it's the right signal, and then look for the right pins. But I added this because I wasted so much time on issues where people saying, hey, this is not working. And then when I checked it, I figured out that they just didn't, like the connections didn't match what the code said. So that's why I added this feature.
Can we go to our first example with ESP32 and you can stop the simulator? We should see it.
Oh, yeah, that's a good example.
Here.
So yeah, if we pause it, we can see like, yeah, these SPI pins going to the clock, the MOSI that are connected to MOSI, clock to clock. And then this D2 is probably DC, data command, and D14 is this one, chip select, yeah. So
cool.
it saved me so much time since I added it. I'm great. I'm thankful for myself to adding it.
Yes, oh, yeah. I like it a lot. I'm pretty sure I will try this. So what do you need to do? You need to register if you would like to use it, or you can try those. Oh, I think you can try it even without registration, correct? Because I was playing with this without registering. Only if you would like to save your project, then you need to register.
Yeah, I mean, now I'm incognito, so I'm nobody in this world. I never registered, I never signed up. I can just go inside. I can look at one of the examples. Let's just take this one.
And you can play with it.
Yeah, play and change the code.
So anyone watching this video and is interested to try it, then they can do it now.
Yeah, hi Robert. Let's compile, and yeah, now totally incognito, and it's very easy to save projects, to share links. And I think the most important thing for me is that people also join the Discord community and share what they are doing. And if they are interested in adding things to the simulator, like we have seen the ePaper and this amazing logic analyzer and scope, I would love to see what else people are capable of coming up with.
And Discord community, how or where they can find your Discord community?
Right in the homepage.
Okay.
At the very top.
Okay. Perfect.
It's a good
I'm
question.
thinking what else. Let's open another game just very quickly. What else you have here?
Oh, this one. This is a crazy one. It's a user, Jim Lee, who created sort of his own operating system for Android with a lot of libraries and stuff. So if you look at this looks like a very small amount of code, right? Like a few files. I mean, a few hundred files each. I wouldn't say it's a tiny project, but it's not a huge project, right?
But there is SD card, I guess. That's
there is stuff on the SD card, a lot of bitmaps, right? But if you look at the library manager, you will see has a bunch of libraries that do a lot of things. That's the LC stuff. That's what he created, or like those operating system or framework that he created for creating apps. And what does allow him to do is to do stuff like this. So there is sound. You can't hear it, but you can like see the game now.
I remember this one. I had this one on my Atari.
Yeah, and it's with sound and everything. And this is actually just one feature in this operating system that he created. I asked him to make it the default so people get right into the game. But if we press this X, we can see he has like other apps that he created. There is a keyboard there that you can use to have input. Like there is this calculator that he has. And like, it's very old school, right? But I mean, it's a game and a calculator. It's just he wanted to create his own handheld with Arduino and LCD.
I'm curious, why was he doing this in simulator? So what is the advantage of using simulator and not doing it in real hardware?
I will be honest. He told me that he did it in real hardware. With real hardware, he did it on a Teensy board. And I think he's the reason that we have, if we look again at the requested features, you can see there is like Teensy somewhere in the list. I think he requested that Jim Lee. And I think that the reason he wanted to port it to the simulator, so to port it to the Arduino Mega and run it in the simulator, is just to share it with others, to show others what he has done.
So that's another way of how this your simulator can be used. If someone has a cool project, they can upload it here and then share the project with other people.
Right. I mean, if you wanted to share a project without Wokwi, the only way you could do it is either physically send it to them,
or they have to build it,
or they have to get all the parts and build it. And I mean, it's so much easier when you just need to send a link, right?
Nice. I really like this. Is there anything else what you would like to show in this video?
I think
I have a question.
Yes.
So the code what we created here, this code is only if you use, for example, Arduino or ESP32, it is for the Arduino environment, or you can use it in, I don't know, ESP IDF, or where you copy and paste this code what you create here?
If you wanted to run it on a physical device?
Yes.
So first of all, you don't have to copy and paste. You can just download project zip with all the files. And this specifically is Arduino code. So if you wanted to use this, it's in the Arduino IDE. And if it's MicroPython code, and with MicroPython, and we also have like some support for CircuitPython, and as I mentioned, Rust. So it really depends on which example you are running. There is also like an example for using the Raspberry Pi Pico SDK directly. So if we just start, somebody actually I think did a few examples with the Raspberry Pi Pico SDK directly, but here is just like a quick example with the Raspberry Pi Pico SDK. So if you wanted to download this, you would actually have to download the Pi Pico SDK and install the toolchain to compile it. But behind the scenes in Wokwi, we do it for you. So just another small projects.
So this is also advantage because you can very quickly start writing the code without installing all the tools.
Exactly. Like if you look, there is a GitHub repo called Wokwi Builders, where we have like all the setup for the build server, and it has like one builder per project type. So for instance, this Pico project, SDK project that we have seen is using this Docker container to build a project. So whenever you are compiling, it's taking this Docker container that has like this we built it ahead of time, the container, but when we built it, it cloned the Raspberry Pi Pico SDK. It installed like all those tools, all those dependencies to run the SDK. And whenever you are writing there some kind of code like this, we are sending this code to that Docker container, running the compiler there or the build process there, and the result is going back to the browser, so the browser could simulate it. So it really depends. I mean, if what you actually looking to do is just to run the code on your device, there is another way you can do it from the secret command menu. You can press F1 and download compiled firmware. That would
so you can even download the binary.
Right, that would. Yeah, I think you can, for the Pi Pico, there is also like download UF2 binary. So there is like this UF2 format that you can just drag into the Raspberry Pi Pico. So you can just download UF2 binary and drag it into the Raspberry Pi Pico and get it on the real device. And I use it sometimes when users post bug reports and they say, hey, this doesn't work on the simulator. I just compiled it in the simulator, download the hex or binary or UF2 file, copy it to the real device, and then compare with the real device. So this is something I use a lot for triaging bug reports and figuring out like if there are any differences in the simulator and the real chip. Spoiler, sometimes there are still bugs in the simulator, but it's not bug free yet.
But it's so much work. I see in your project so much work done, like wow.
Thank you, Robert.
It really must be like a lot of work to create something like this.
Yeah, a lot of work, a lot of patience, and also lots of help from users. Like I could have shown you like on GitHub pull requests and bug reports that users are sending. And I mean, we have seen the custom chips that users are creating, like the scope and the ePaper display. They are doing amazing things. And I think if we give another shout out to some community member today, you see like we have all those docs. There is some guy, Anderson Costa from Brazil, who translated everything into Portuguese. And he keeps updating the Portuguese version every time we make changes. So it's very up to date. And I mean, he's doing it for free, is helping us out with Wokwi so much. So yeah, this is a lot of work on my end, right? But there is also a lot of support and a lot of contributions from the community, which makes this possible.
Very nice. I'm very happy we created this video, and as I told you, I may really use this.
Please do.
in my new project and try it, because sometimes I think it can be super helpful and very quick way to test simple things. There is one more thing what you mentioned last time. Some companies even use it during interview.
Right. I discovered it like a few months ago. Somebody wrote me that he was using it for interviews. And then 2 weeks ago, somebody said to me, somebody told me that he used it in like he was interviewing for a job and they gave him assignment on Wokwi. I don't know yet. I need to ping him again and ask him if he passed the interview. But it's interesting to see that companies are actually using it to help them filter candidates and give them home assignments. Yeah, it's like I never anticipated this use case.
Interesting idea. Okay, I think that's everything for today. So thank you very much, Uri, and yeah, thank you for all this work what you have done.
Thank you, Robert. Great to talk to you.
And that's everything. Thank you very much for watching this video. By the way, we are preparing some very interesting tutorials, so if you don't want to miss them, hit the subscribe button. If you want, you can also check out our FedEval online courses, where you will find everything important from basic board design up to advanced hardware design and PCB layout. The link is in the description. That's all for this video. Thank you again. Don't forget to leave your comments and see you next time. Bye.